Okay, class, I'm going to do a quick run through of the review packet, so I will answer everything, but you might need to press pause in places if you're trying to copy down work and sort of get the same types of things. It's always a good idea to sort of press pause and then sort of keep working forward, and then you could press play and see if you're getting the same thing, or you can just use this to check your answers if you want to as well. So going through here, we're looking for positive, negative, or neutral, no correlation. Okay, so A, we have the line going uphill, so this is positive. So even the data points are a little bit more scattered out. We still have this general upward line happening. B again is uphill, so it's positive. C is downhill, so it's going to be negative. And D is going to be neutral or no correlation because the points are kind of everywhere. Okay, number 2, we only have options of picking positive or negative, so make sure we're sticking to those 2. Right, we're going to check and see what happens with the general trend of the data as we go from top to bottom. So X is increasing, but Y is decreasing, so this is going to be negative. Oh, no, increasing, sorry. Increasing. So this is going to be positive. B is increasing, the X is increasing, the Y is decreasing, so this is going to be negative. And then C, the X is increasing and the Y is overall increasing, right? So don't go from spot to spot because we'll see increasing, decreasing, but overall it's increasing. So this is going to be positive. Number 3, 40 students were sampled. Which sample would provide a more valid sample of Westfield High School? So if we're looking at Westfield High School, that means we want to include students. We want to include all grade levels, and all of our grade levels are pretty much distributed evenly. Obviously, we have some classes larger. So while these numbers wouldn't have to be exactly the same, right down here we're 2 different, so that wouldn't be the best. Okay, this doesn't include all the grade levels, nor does this one, so we would pick option A. Number 4, Alex took a poll to decide what the most popular clothing store is for freshman students. 30 freshman girls were asked during B lunch about their favorite brand of clothes. American Eagle was the most popular brand. So was this sample random? Okay, we would say that this is not random. Okay, and the reason why is because they were only asked during B lunch. Okay, I'm not sure I'm going to write down all the explanations here. That might take too long. B, we have lots of options. How might Alex's data be biased? It could be biased by how he asked. Maybe it's a she, I guess. I don't know. The clothing that they were wearing. You could write something about maybe other students saw how they responded. Maybe they only asked a group of friends, and so all those friends were picking the same thing. Anything that's sort of causing them to respond differently. Okay, so then C would be attached to your B. So maybe he could have had students respond on a piece of paper or put their heads down. Make sure that he wasn't wearing American Eagle clothing. Is this sample reasonable to make predictions about teenagers' favorite clothing store? We would say no, because we only asked freshmen, and that's not teenagers as a whole. Number 7, we're deciding random or non-random. Heather asked all students at her lunch table their favorite color. This is non-random because we asked by ease, just at your lunch table. Nathan assigns each student a number and then uses a number generator to pick 100 students to participate in a survey. That would be random, right? Everyone had a fair chance of getting picked. Number 9, we're going to need to graph this data. So our X's are going to go on the x-axis. Our Y are going to go on the vertical axis, and we need to space evenly. So we need from 2006 to 2015. So I'm going to count by ones down here. Again, remember the rule is that you have to count evenly. You cannot just label the values that you see and just go one blank at a time. Okay, same thing going up the Y. We need to count evenly. So if we need to get from 225 all the way up to 525, let's see. If we do 253, 354, 455, 550, we could maybe count by 50 cents. So if we do $2, 2.5, 3, There would be other appropriate ways to count as long as you're spaced evenly, right? So now I need to plot all these points. So I need to plot 2006, comma 2.25, and so forth. So 2006, 2.25, 2007, 275, 2008, 350, 2011 is 425, 2013, 2015, okay, then to get the equation of the best fit line, right, we need to find 2 points that do a good job of representing this. You couldn't pick, for example, 2007 and 2009. That would be way too steep. So we need something that's going more this way, so maybe here and here. So those would be the points 2007, comma 2.75, and 2015, comma 525. These are not the only correct points that you could pick, so if you have different numbers, your work might look a little different. So if we want to write the equation of the best fit line, we are going to find the slope first. So that's going to be a y minus a y. Over an x minus an x. We're talking about money, right? We don't want a decimal in a fraction, so this is going to give me 0.31. Then I need to plug into point slope form, so I have a slope. How about I use one of my points? Y minus my y coordinate equals m times x minus my x coordinate. I'm going to distribute. Add that over. Okay, so our equation that's going to go in this blank is going to be y equals 0.31x minus 619.42. So if I now want to approximate the year 2020, I'm going to plug 2020 in for x. I'll get $6.78. Oops, that should be a dollar sign. Okay, number 10 through 14, we're talking about the table up above, our frequency table. So how many of the total sample were under 25? So we want the total sample that were under 25. So these are people under 25. So we'll add those up and get 51. Okay, what percent, so we know for a percent we need a fraction, what percent of the sample 25 and older, that and doesn't need to be there, what percent of the sample 25 and older, so let's see, 25 and older is 37, did not have a college degree, so that would be 30. When we divide those out, we'll get 81.08%. 12, what percent, let me get a new color here. Okay, so what percent, so we know we need a fraction, of those with a college degree, so with a college degree is going to be here, so that's going to be 41. We're under 25, so 34 out of 41. It's going to give us 82.93%. Number 13, what percent of the total sample, so we need everyone added together, it's going to be 88, have a college degree. So having a college degree is 34 plus the 7, which is 41. So we'll get 46.59%. Okay, and then from this data, what can we infer? So if we look at this, right, there's more people who have a college degree if they're under 25 than if they're over 25. So we would say that people under 25 are more likely to have a college degree whenever this data was collected. 15, a Crest toothpaste commercial reports that 9 out of 10 dentists recommend their toothpaste. How might this data be misleading and whose interests might they be trying to serve? Okay, so, right, we've sort of talked about the fact that it could be that they just asked them if they would recommend Crest toothpaste and didn't ask about anything else. It could be that the dentist said they would only recommend toothpaste of any type. It could be that they were the same people offering them free samples, right? They could have picked what specific dentist they wanted to ask. Any of those options would be fine there. It'd be serving the toothpaste company. Number 16, we need to read each of the following and circle any statements that are causation. So remember, causation is anything that is a direct cause and effect. So a better basketball player will get to start more often. That is not a direct cause and effect. It's definitely a correlation, but not a causation. B, the ice cream will melt quickly on a hot day. That is a causation. The heat is making the ice cream to melt. People who live in warm climates like ice cream more. That would be a correlation, not a causation, so we don't want to circle that either. Okay, then if you need help with the graphing calculator portion, you're going to want to access the graphing calculator on Canvas. So there's a link on the home page. I'm going to go through all the steps here, but you can access the calculator with the link and you'll have it on your device. Okay, so first thing is we want to make sure our calculator's on, which mine is. Second, and then 0, we're going to arrow down to diagnostics on, so you can sort of check that your screen is looking like mine. We have to enter again to turn that on, right? We should see done. So we'll press stat. We'll press 1. We don't have anything to clear. So we're going to enter our data into the table. So I'm going to go down and do the X column first. Feel free to press pause if you can't keep up with entering it as fast as I do. And then we'll enter our Y values. Okay, then once we have all the data entered, we are going to press stat. Okay, we're going to arrow right to calc, press 4, and then enter. This R is going to be our correlation coefficient. If you don't see the R here, then you did not turn your diagnostics on. Whatever, just give me some decimals is fine. Okay, then we'll keep going. We'll press Y equals. Okay, our plot 1 is not black, so we're going to move our cursor over it and press enter and then move it off. Press graph. Press zoom. Then press 9. We're going to press Y equals. We don't have anything to clear out. We're going to press vars. Press 5. Move the cursor to EQ. Press enter. Okay, what we see here is going to be the answer to 18, so you have to have that Y equals 0.112. I'm just going to round. You have to have the X, right? I rounded the number in front of it, but I still have to have the X, plus negative 225.27. Okay, we're going to press second, then mode. Press vars. Move cursor right to Y vars and then press enter. Hit enter to select Y1, right? We're going to see Y1 on our screen, not inside of our equation, but on our main calculator screen. And then inside the parentheses, we're going to enter the value we want to predict. So we get 2.41. Okay, you're going to need to know that you have to start back over at 18 to do the calculation for the second one. So we'll press vars, move to Y vars. Hit enter to select Y1. And then our next prediction is 2025, which gives us 3.32. If we round, Okay, so while some of these answers you might have slightly different work on, these should be exact. If you have more specific questions, go back and watch the videos from the days that cover the specific topic.